Hi everyone, this video is for people who are missing class when we're talking about how to use statistics to determine the probability of an offspring in a multi-characteristic cross. But I want to start this recording with a practice problem that some of you have done and some of my classes have not done. So I would like you to try doing this dihybrid cross. Pause the video, and then you're going to check your answer when you start the video again. If you've already done this dihybrid cross in class, please simply fast forward. So I'm going to give you time to pause now. Okay, I'm back. Let's look at the answer and see how you did. So in this particular question, I used an uppercase H for longhorn and a lowercase h for short, and an uppercase G for green wings and lowercase g for gray. And if you do this cross, you find that you can do it as a 4x2 because this second parent here is only going to produce 2 different gametes. And you find that the question asked for what's the probability in fraction form of a shorthorn green winged dragon, and you find 1 possibility out of these 8. So that's a 1/8 possibility. Now, what about if we do a cross with 3 or 4 or 10 different characteristics? That Punnett square is going to get so large it's really not manageable. So I'm going to give you a shortcut. So my example is I'm just going to give you the alleles that are being crossed, because if I give you descriptions, it ends up being paragraphs long by the time I describe 3 or 4 or 5 different characteristics. So in this case, I am crossing one parent that is heterozygous for A, heterozygous for B, and homozygous recessive for D, times a parent and mating with a parent who is heterozygous for A, heterozygous for B, and heterozygous for D. I want to know what the probability is of producing an offspring that is homozygous for A and homozygous for B and homozygous for recessive D. That would be a very large Punnett square, but there's a way around this. What we can do is figure out the probability in fraction form of each individual characteristic. So I've put the cross up here again so that you can see this is the parental cross. What we want to do is just look at the individual characteristic. So in this case, in this first cross, I'm just going to look at the A characteristic here. And in this case, each parent was heterozygous for A. So I will have a big A and a little a and a big A and a little a for each parent. And if I fill this in, I will come up with this Punnett square. My question also asked, what is the probability of forming an offspring that had homozygous dominant for A? And our probability for that is 1 out of 4, because that's right here. Let's go on to the B characteristic. The parents were again heterozygous, so I would do the same thing I did before, and I will fill in my Punnett square. And again, my question asked, what's the probability of a homozygous dominant for B? And again, I just have 1, so that would be 1/4 again. What about my D characteristic? I've reproduced the probability here. So the parents were homozygous recessive for D and heterozygous. So I would put my one parent here, my next parent here, and I'm filling in. And my probability of lowercase d, or homozygous recessive, is 1/2. Now, what do I do with these fractions? Well, what I'm going to do is I need to multiply each of these fractions together to get the overall possibility. So 1/4 times 1/4 times 1/2. You probably haven't multiplied fractions since about 4th grade, so let's review that rule. When you're doing this, you multiply all the numerators, so 1 times 1 times 1 equals 1, and you multiply all the denominators. So 4 times 4 is 16, times 2 is 32. So the probability of that crossing that I showed you producing a homozygous dominant A, homozygous dominant B, and homozygous recessive D is 1 out of 32. I must caution you that the place I see students making the most mistakes on this is in the multiplication, the math of multiplying fractions. So please do that very carefully. And this is all you've missed in class, and you should now be able to complete the Punnett square problem set.